we go through the Russian segment, we're going forward into the United States segment. This is the long axis of the space station. We come all the way to the front part of the space station. So that was about the length of a football field or a soccer field. So it's really, really big. So a question that I get a lot is, do you get claustrophobic in space? And the answer is no, because the space station is unbelievably huge. When I was there were only 2 other people there with me, and at times, if I was working up at this very front part of the space station and Mike and Yuri were back in the Russian segment doing something, I felt like I was by myself. And I could hear them communicating with the ground, but I could not see them. I had no idea where they were. I had no idea what they were doing. It's like being in your bedroom in your house with somebody in the kitchen, and you know they're in the kitchen, but you don't know what they're doing. You can't hear them. And so that's kind of what it was like to be on the space station. What do we do on the space station? One of the 2 biggest activities that we train for, that we're asked to do, are these spacewalks and then the robotics. And the robotics can support the spacewalks, or you can do spacewalks without the robotics. And these are very important tasks. We do a lot of training for these tasks because they're very hazardous, and you must know very well how to run, manipulate the arm and drive the arm. And of course, the spacesuits require a lot of practice in them. And we practice in a very, very large swimming pool in Houston. We have a complete full-scale mock-up water, and that's how we practice. For robotics, we have a lot of different kinds of simulators, and we practice the robotics in the simulation. Before the cupola arrived, the cupola is this very wonderful module that went to the space station after I came home, unfortunately, but it's a module that has windows 360 degrees around, so you can see outside very well. And we put the robotics control station in the cupola so you can watch the arm while you're flying it. While I was there, in order to understand where you were flying the arm and where it was moving on the outside of the station, you had camera views. So you had to look at 3 different camera views and figure out from those camera views where the arm was going and what it was doing, and that requires a lot of practice. When I was there on STS-135, the cupola was there, and it was very nice to fly the arm and see it while I was flying it. It was much more comfortable. We also do a lot of science on the space station. So we train for spacewalks, we train for robotics, and we train to do a lot of different science experiments. We have science experiments from all over the world. The scientists have a team. They work together to make sure that the research is very complementary, that we're not repeating research. To say Germany doesn't put an experiment up that's the exact same copy of an experiment that Japan is flying, for example. So they coordinate the research in an international way. And these are the different areas that we do science on. And at any given time, I could be called to do any one of these activities. We do a lot of that, actually. That's a nice, by the way, this is a very nice picture of the space station taken with the space shuttle attached. This was taken by a Soyuz crew, actually Paolo Nispoli from Italy, took this from the Soyuz as they were undocking. Their crew happened to be undocking and coming home or returning on a Soyuz while the space shuttle was docked to the space station. And it's a very, very special picture. It's a very, very unique picture. And it gives you, I think, a feel for the size of the space station. You know, you've seen pictures of the shuttle, and for those of you who've seen shuttle launches, you understand how big the space shuttle is. And so you can see the scale of the space station in this picture. The video that you saw of the space station started back here and went all the way down the axis, and that's about a football field. And then from this end to this end is also about the size of a football field or a soccer field. So it's very, very large. But this is a very special picture just because it has that space shuttle attached. This just gives you a share of, this is some old data, but this gives you an example of the kind of research that different countries are doing and have been doing. It's about 2 years out of date, but the trend is the same. Between Canada, Europe, JAXA, NASA, and Russia, there's a variation in their interests. You can see the Japanese are very interested in biology and biotechnology. NASA has a little bit of everything. You can see that the Canadians are very interested in human research, and the Russians have a lot of technology on the space station. So each country has different interests, but as I mentioned, we work together to make sure that we're not repeating each other's work. We do a lot of maintenance. So we do science experiments, we do outreach, we do maintenance. We have to do house cleaning every weekend. I had to vacuum, clean the walls, and things like this. So you still have to do your housekeeping in space. It's not free. We do a lot of maintenance on equipment. We're constantly working on the inventory and the stowage. So I was an electrician and a plumber and a mechanic, as well as a scientist and a technology person and a robotics operator. You must exercise on the space station in order to maintain your bones and your muscles. We have 3 major exercise machines. This is a resistive exercise device. It simulates weightlifting by you pull against a vacuum, and you can do things like squats and bench presses and things like this that work all of the major muscles in your body. Very, very important, very, very effective. We have a treadmill, and you can see you put on a harness and you bungee yourself to the treadmill, and that's how you run. This is a very good exercise for getting a dynamic load on your bones. And I could lean forward in the harness and I could get more weight on my heels. I could lean back in the harness and I could get more of the load on my hips. So that was a very good way to work the dynamic loading of those 2 muscle systems. And we have a bicycle ergometer. This was a very good workout for my heart because I could get on the bicycle, I could pedal very fast for a minute or 2, and then I could rest. And then I could pedal very fast for a minute or 2 and I could rest. And so for my heart muscle, that was a very, very good way to maintain my cardiovascular health. Food. People always ask about food. In the space station, we have 2 galleys, two places to eat. There's one back in the Russian segment and this one here in the node. Our food comes in cans. Russia launches cans. The United States has dehydrated food. You must add water, or food in a pouch that you just heat up. And it's the same food every 10 days. So you have a menu that goes for 10 days. The next 10 days, almost the same menu. So the food is, it's good, but it gets very repetitive because it's the same food. We get fresh food when the cargo vehicles like the Progress, or the shuttle, or the ATV, or the HTV, or the SpaceX Dragon, and now the orbital Cygnus, they bring fresh food. Apples, oranges, tomatoes, onions, garlic. And I have to tell you that I was there for about 2.5 months, and a Progress vehicle came. We opened the hatch, and you could smell the fresh citrus of the oranges in the Progress vehicle. It smelled so good. So we're very excited to get fresh food. The food containers look like this, and they're organized by vegetables, meats, drinks, and so you go to each container to get your food. Our crew tried to eat together every day, and we shared our food. It was a lot of fun. Eating in space is not that difficult if the food has some moisture in it, because with the moisture, that allows the food to kind of stick to the spoon. But things that are dry, like popcorn, potato chips, things that create crumbs like bread, can be very difficult, because if the food is dry, if there's no moisture, no liquid in it, it does this. And it goes everywhere. And it can be very dangerous, because you can imagine all of the sharp little crumbs you get from potato chips or popcorn. You don't want to get that in your eye. Here on the ground, those kinds of things fall to the ground because gravity puts them on the ground, but in space they float around. So you have to be very careful when you eat. As a matter of fact, one crew member managed to get some wasabi in their eye because the wasabi was floating around, and that was actually a very dangerous moment. Sleeping. Sleeping in space is probably one of the things that people have the hardest time adjusting to, because you're used to having that feeling of gravity holding you to your bed. And so what I did is I had some bungee cords. You can see one across my chest. I had some bungee cords, and I bungeed myself into my sleeping bag to the wall so that I could feel constrained, and then I was able to sleep. And we each have our own little closet, little small space that we slept in. And you can keep personal items and things like that in it. And in note 2, we have 4 sleeping quarters right around each other. So everyone has their own private space. And so that's a very good thing. It's important to have a little private space. Relaxing, you know, there's a lot of fun things you can do to relax. We do, where's the mouse? Here we go. We have our stupid astronaut tricks. This can make you very dizzy if you do too much of it, but that's kind of fun. When I was there in the last shuttle mission, we tried to have dinner together every night. This is down in the Russian kitchen area. We had dinner together down there. We had dinner together in the shuttle, and then we had dinner together at the Node 2 galley, the one you saw on the previous picture. We have Russian food, American food, Japanese food. The Europeans are working on some food, so there's quite a lot of different food. By the way, this is a picture of the cupola. I mentioned the cupola, the 360-degree area where the windows are. This was a wonderful place to spend time looking at the ground. Would you guys like to come in and sit down? Come on in. Don't be shy. So the cupola was a great place to go when you had time to relax, because you got such a wonderful, wonderful view of the Earth as it surrounded you. You could look all the way in a full circle, and you could see our planet, and you never got tired of looking at the planet. You see things like this. These are some pictures. One of my favorite places to look at, and I never got tired of it, was the Caribbean, because you can see the whole Caribbean at one time. In the Caribbean, there are a lot of different changes in the depth of the ocean. So where it's very, very deep, it's very, very dark blue. As you go to the islands and it gets shallow, you see the color changes. And from on orbit, it looks like a piece of modern art. It is absolutely beautiful. I spent a month trying to get the perfect picture of the Caribbean. It's just beautiful. Just to give you an example of the difference between day and night, this is Italy during the day. This is Italy at night. So when you're on the night side of the planet, you can see very clearly where everybody lives, because all of the cities light up. And in Europe, where there are very, very many people living, you can see the whole continent very clearly. Central Asia, as you know, there aren't so many people in the center part of Asia, and so Central Asia is very dark. The coastline is very bright. The coastline of almost every continent is very bright because many people live on the coastlines. So you can really see where people live around the world. And then this is a movie that shows you, let's see if it plays. This is a movie taken by some space station crews that gives you a pass at night coming up into the southern United States. This is Florida, that's Atlanta, and as you come up through the United States, you can see you have the whole Washington, D.C., all the way up through New York, into Boston, up into Canada. You're coming up over Canada, Newfoundland, up into Greenland and Iceland. You can see the Aurora Borealis, and so you get these kind of views. You never get tired of them. Sometimes I get questions from children asking me, well, do you miss TV? And I say space station and some of the things that we do there. Hopefully that was enough to generate some questions. And I'd like to now turn this more into a dialogue so we can talk together as opposed to me just talking to you. So I'll let you run around and look for questions.
If you have any questions, just raise your hand and I'll come to you. Okay, let's start over here.
You told that you will stay there for 4.5 months. Would you ever call your family and say, hi, I'm calling from space?
Yes, we have. it's really amazing because I felt like I was on a business trip because I had email. So 3 times a day, the ground would send our email up, and so I could send emails to my family. We actually have a telephone on the space station that we can make phone calls to the ground when we have the right communication system set up, which is most of the time. So I could call my family and my friends, and I really had fun with that because I would call, and then a friend would answer, and I would say, space calling, you know, and we had a lot of fun with that. And then every Sunday, I could have a video conference with my family. And so there are many, many ways to stay in touch with your family and friends. It's kind of interesting because you're separated by 300 kilometers of vacuum, but you really just feel like you're on the other side of the world because the technology we have is so amazing that we can stay in constant communication. As a matter of fact, Mike Fink, my crewmate, was working on a science project with his son. And so he would call home in the evenings to work with his son on their science project. So it's really amazing how connected that we can be, not only around the world together, but to space. It's amazing. There's one at the back.
Hi, Guillaume Girard. I'm a flight controller for the Columbus Laboratory. Yeah, I mean, there is a lot of questions from everyone. I just wanted to take advantage of this one and get a bit onto the isolation part. You have a lot of communication, but sometimes something can happen on the ground and you cannot come back to Earth, and you have to deal with that. And it can be something in your family and something that will call you to come in. If you will be on a business trip, you will really cancel your business and come back. Can you tell us how would you deal with that? And for instance, in the case of Paolo Nespoli or someone else.
So I believe you're asking about if there was an emergency with my family, for example, while I was in space. Let's say my mother was in the hospital, or a child was ill, or maybe we had actually several cases where a parent has died. You know, one of my colleagues, his mother was in an accident and died while he was on orbit, and one of the Russian cosmonauts had a similar experience. So what they do is before you go on your mission, you talk to your flight surgeon, and you tell your flight surgeon how you want to be notified if there is a family emergency, and who do you want to have notify you. Do you want the flight surgeon to notify you? Do you want your spouse or someone to come into mission control? Do you want the lead flight director? They have ways of securing the communications between mission control and the space station so you can have a private conversation. Because you cannot come back. If something would have happened to my mother, my father's already deceased. If something would have happened to my mother while I was on the space station, I wasn't going to be able to come home. And so you have to be able to deal with that. And so the most important thing that we all value is communication, and clear communication. And the worst thing that can happen to you on space station is to not have good communication with what's going on. So before you launch, you make it understood what kind of communication that you want, and who do you want to communicate with you. And that's basically how we deal with that. That's the only thing that you can do, because you're not just going to come home. So it's a consideration that we all take into account when we fly. Luckily, it hasn't happened so much, but it can.
Sort of piggybacking off of that, what is the toughest psychological challenge you've had to deal with living on the space station or just being an astronaut in general?
What is the toughest psychological challenge that I have? So that's two questions, really. One, what's the toughest psychological challenge being on the space station? And then what's the toughest psychological challenge of being an astronaut? Because those are actually two different questions. So I'll deal with the space station one first. I think probably it's just making sure that you stay busy and occupied while you're on the space station. And this is part of the answer to the other one too. So people who are astronauts tend to be somewhat high energy and very engaged and very active, and you want to feel like you're doing something useful. And when you live on the space station, of course, you're not as busy on the weekends. And so it's a very good idea when you plan a mission to the space station to have a project of your own that you're going to do in your off time. So for example, what I like to do at home, I like to cook, I like to read, I like to go outside and run or hike. I couldn't do some of that on the space station, so I had to come up with some other thing to do on my off time. So I did a lot of educational videos. I like to organize things, so I actually did a lot of organization of the stowage because it was such a mess. So it's important to keep yourself occupied. And I think this, when you talk about going to Mars, and you're sending people on a 6-month journey to Mars, one of the challenges is going to be, what is the crew going to do during that journey? You need to find a way to keep them engaged and occupied. Because just sitting in a tin can, hanging out for 6 months is not good. So that's a very big psychological challenge. So do you plan some training for them? Do you learn a language? I mean, you need to have something to keep the crew occupied. So that's a big psychological challenge. Now, in general, for being an astronaut, there's the astronaut job is very fun because not only did I get to fly in space, I got to learn something new every day. I learned everything from photography to how to draw my own blood, to how to do emergency procedures on people, to life sciences, to the Russian language, to all of the space station and the space shuttle systems, a little bit of Japanese. I mean, I was learning things all the time, and that's very fun. The hard part is you're constantly traveling, because to train for the space station, I spent a month in Houston, a month in Russia, a month in Houston, 2 weeks in Germany, a month in Russia, a month in Houston, 3 weeks in Japan, 2 weeks in Germany, 2 weeks in Canada, a month in Houston, and I did that for about 3 years. And so that can be very tiring. And I don't have a family, but for people who have a family, you have to manage that very carefully with your spouse. So that can be very demanding. So that's a very challenging thing. It's actually easier to fly in space than it is to train to fly in space.
Well, since there's so many astronauts from different countries, so what time do you use the ISS?
So yes, we have control centers in Moscow, in Munich, in Houston, in Huntsville, and in Tokyo, and in Tsukuba. And so we all sync up with Greenwich Mean Time, or Universal Time. And so everybody works on Universal Time, which is the time zone, of course, that goes through London, England. And so we all have that operational synchronization. So I used to get up at 6 in the morning, Greenwich Mean Time, and that meant it was 1 o'clock in the morning in Houston, and 9 o'clock in the morning or 10 o'clock in the morning in Russia, and somewhere in between in Europe. And so all of the control centers adjust their operations to Greenwich Mean Time, or Universal Time. Otherwise, it can be very confusing.
Thank you for exciting presentation. And what is the most challenging thing to be a best to construct the best teamwork with your crew till the end of the project?
So what is the most, I'll repeat the question and tell me if I got it right. So what is the most challenging thing to create a team to be successful in your mission, right? So the most important thing you need to do, and I like to think of my crew as my family, because just as for those of you who have brothers and sisters, you know your brothers and your sisters very well. You know, for example, exactly what you can say to your brother or your sister to make them mad, right? And you know exactly what your brother or your sister is really good at. And so to form a really good crew, that's exactly how you have to be. I know my crews so well enough, and they know me, that they know exactly what I'm good at. They know they can tell when I'm tired. I can tell when they're tired. I can tell when they're happy. I can tell when they're sad. I know what their strengths are. I know what their weaknesses are. And so you have to get to know your crew that well, because then you can work very effectively. effectively as a team. So for example, if I knew that one of my crewmates needs food every 2 hours, you know, some people need food every 2 hours and some people only need food once a day. But if I know one of my crewmates needs food every 2 hours and we have a 6-hour activity and we don't get food every 2 hours and that particular person's going to get a little crabby, I know why that person's getting goes, oh yeah, we haven't eaten for 4 hours, now I know why he's crabby, you know, and you're not upset that maybe he's a little crabby. You go get that person some food and say, you need this food. So having that good understanding of your team and your people on your team helps you work very effectively. But it takes some time to get to know another person that well, let alone a team of people, but that's what we do.
Could you please a little bit more describe how you become an astronaut and do you miss the space? Do you go back?
Yeah, so the question is, can you describe how to become an astronaut? And I can do that from the United States viewpoint. Do I miss space? Of course. Would I go back? In a heartbeat, I would go back. It's a very, very special place. And when I'm there, I feel like I belong there. It's my second home. And I do miss it, but you know, we all have our share of flying, and it was time for me to move on. So in the United States, to become an astronaut, you are basically a government employee. So you have to first apply to be a government employee and at the same time apply to the astronaut program. To be competitive as a candidate, it's very good to have a master's degree. You do not require a doctorate degree, but it's helpful to have a master's degree. And it should be in a science or a technology or an engineering field. We do accept medical doctors as well. You can apply as a civilian, you know, a non-military person, which is what I am, or you can apply as a military person, in which case they look for people who are pilots or flight engineers. We've had Navy doctors or veterinarians, so the military has a little bit of a separate thing. When you apply, they look for people who, of course, have the technical qualifications, people who are well-rounded, because you have to be physically fit. They look for people who can communicate so that you can stand up and explain what you're doing. And that's sort of how it goes. You make an application to NASA, and this last selection, we got, I was still working at NASA at the time and was involved. We had about 7,400 applications. We always interview 120 people. Part of the interview is medical tests. So when I went through my astronaut selection interview and medical test, I knew that if I did not make astronaut, they were going to find out if I was healthy or not, because they tested everything. So there's a lot of medical testing involved, especially for space station. And then you have the interview, there are some psychological tests. And then this year, out of the 120 people that were selected, they took 8. So they went from 7,400 to 8. When I applied in 1996, they received, I think, about 3,000 applications, and they took 35. So the odds were better when I applied. But that's sort of how the process goes. So you basically apply to the government, there's an electronic form, and then NASA starts evaluating all of the applications to look for the educational background, the work experience, are they well-rounded, do they do, you know, things like that. It sounds easy, but it takes some time. The process takes about a year. Once they say the deadline for the applications, the whole process to go through the applications and check all of their references and figure out who they want to interview, and then decide who to hire, it takes about a year to go through that whole process. It's very involved because they want to make sure they get the right candidates.
Yeah, my name is Ahmed Farid, Columbus Control Center in the ground control team. Actually, I know that working with space is, with the time, is very fast. So I want to know how fast was the 2.5 months for you, and did you sleep for the first night when you catch the space station?
So time, it does seem to go very fast because you're very busy. And that's interesting because A space shuttle mission where you just visit the space station and do certain tasks for 10 days or so is very different than a space station mission where you live on orbit for months and months and months. So a space shuttle mission goes very fast because you don't even have a chance to stop and relax. A space station mission, when you live there like I did, I think it went by, looking back, I think it went by very fast. There were times that it felt like it was, you know, when you go to work sometimes, some weeks are just, oh my gosh, this week is taking forever. So we have weeks like that as well, but it does go by very fast because you do maintain a certain level of activity and you are very busy. And sleeping, as I mentioned in the presentation, sleeping is very difficult, and a lot of people have to use a week or so to adjust. It took me about a week and a half to adjust to sleeping, and the reason was I found out that I'm very sensitive to noise, and I did not know that. The space station has a fairly high noise level, and even you saw a picture of me in my little closet with the door closed. There was about a 40 dB noise level in my closet, and that was still too loud for me, so I slept with noise-canceling headset on my head. And that's how I was able to finally sleep well. Some of the people who come on the shuttle and are in space for only a short time never really adjust well to sleeping in space. But I was able to with the noise-canceling headsets. That's my problem. Now, some people don't need them, but I need them. I did not know that before I went to space. Oh, I don't like noise.
Hi, I work at NASA Marshall, and part of my work relates to station. We're just entering kind of the era of utilization for station, and it was just designated a national laboratory a couple of years ago. I can't hear you.
Hold it close to your mouth.
Oh, hi. Okay, I'm Tracy. I work at NASA Marshall, and part of my work relates to station. Since we're entering the era of utilization, and the station was just designated as a national laboratory a couple of years ago, how likely do you think it is that the life of the station will be extended possibly to 2028?
Okay, so the question was, now that we're finished with the assembly, which took about 12 years, and we were doing science the whole time, but our tasks were split between science and assembly. Like when I was on station, I built the toilet and the exercise device and the crew quarters. So now that we have the station assembled completely, we can do science full time. But the question is, right now, the station is scheduled to be used only until 2020. There are people looking at extending the life of the space station to 2025 or 2028. The question is, what do I think about the possibility of that happening? I think it's highly likely because you don't spend the kind of money and time and resources that we have to put this wonderful laboratory in space and just arbitrarily decide, oh, we're going to stop now. So it doesn't make sense to me. And I think we're going to find, now that we can use it to its full capacity, we're going to learn things that we did not expect. And the longer we can use it and the more we can do there, the more opportunity for learning we're going to have. So I believe there's a good chance that will extend beyond 2020. They may do it in a short, like 2022, oh, let's go to 2024, oh, let's go to 20. So it may be sort of a painful way to extend it, but I think that we'll extend it. It just makes sense. Yeah.
So you mentioned the space station is very noisy. So where does that noise come from?
So the noise, the question is, where does the noise on the space station come from? So, you know, computers have fans for cooling, so there's fan noise. The Russian segment uses fans for cooling, so you got fan noise. The Russian side and the American side have fans that help blow air through the station for circulation of air, so that's noisy. Some of the valves, when you open and close valves in the plumbing system, they make noise. So there's a lot of noise, and a lot of it is cooling equipment and fans and things like that. In the Russian segment, they also have some oxygen generation equipment that has some valves that are very loud. A lot of it's fan noise. Fan noise. It could be anywhere from 45 dB to 65 dB, depending upon where you are in the space station.
Hi, my name is Katrina Lego, and I'm from the George Washington University. And you mentioned that you did a lot of travel before and after the tour as an astronaut. Are you, or do you know of NASA's current status in collaborating with, say, developing regions to build their capacities for human spaceflight?
So the question is, am I familiar with what NASA is doing in developing nations? I am not familiar. I departed from NASA about a year ago, and so I am not aware of what we're doing there for encouraging, I think you're probably talking about research on ISS. Yeah. I hope that they're doing something, but I'm not familiar with whatever those efforts are. I think it's interesting. We live in a very interesting time because there's more and more access to space. And I'm not talking about just countries. We see more countries accessing space, but there are students who are building CubeSats and launching them. So it's not just governments that have access to space or companies that have access to space, but there are students around the world that are launching small satellites that they're building in their laboratories at the university and accessing space. So it's a kind of a new era there with this sort of availability for people to launch things. And I don't know where it's going to go, but I think it's all good. So I can't answer your question though.
Space inside the station and how you move.
Yeah, so the question was about microgravity effects on how we move. And actually, I think the bigger effect, rather than the microgravity effect, is the lack of a reference system. Gravity is a reference system for us. Up and down have a meaning because gravity is holding you down. So on the space station in microgravity, you don't have that reference system. What you naturally use is the up and the down that you're used to seeing in the simulations when you train. So when we have our full-scale space station trainers that we work inside during our training, and of course you're always standing on the floor because we have to train in gravity. And so that becomes sort of the floor, and the ceiling becomes the ceiling. And so on space station, that's your natural reference, but it's very easy to get disoriented. So for example, when the shuttle was docked, I would fly through the shuttle hatch, and to go from the shuttle to the space station, you had to go around a corner and make a 90-degree turn, rotation, and then you come into the space station and to stay oriented on the floor. Well, it's easy to over-rotate, and then you come into the space station and maybe you've rotated an extra 90 degrees, and right there in the node where the shuttle is docked, there's the Japanese module, the Columbus module, that's the laboratory module, and sometimes there's a cargo module here. And if you're rotated 90 degrees, you look this way and you expect to see the cargo module and it looks like Columbus, and then you're confused. It's like, that's not what's supposed to be there. So it's very easy to get disoriented as you translate if you're not paying attention to your rotation. So usually what I did, if I noticed that I lost the floor, if you will, there are certain landmarks that I used. I looked for the robotics workstation because I knew the robotics workstation was on the port wall. It's like, oh, there's the robotics workstation, and it's over there, so I must be facing this direction, and you can reorient it. So you find landmarks to use as a reference frame, because up and down have no meaning. It's kind of interesting. And our brains are used to that, so you have to retrain your brain.
What do you think is the most different between the ISS mission and the future Mars exploration mission as an astronaut?
So the question is, what do I see as the big difference between the ISS mission and a future mission to Mars? You know what I think the biggest difference is going to be is the view out the window. Because on space station, I can look out the window and the Earth, it's right there. It's big, I can see the horizon, I'm very close to the planet, I feel that I'm not far away from the planet. When you go to Mars, you will not see the Earth at all. You will not see the Earth. Not blue dot. Think about trying to find Mars right now in this night sky. It's a teeny tiny little red dot. And so your sense of isolation and your sense of being disconnected from the Earth is going to talk about psychological, that's going to be very different. And then we talked about earlier, you need to be able to do engaging, interesting, challenging tasks on the way to Mars. Also, on the space station, psychologically, we all know that if we have a problem, we can come down to Earth in an hour or 2 or 45 minutes or whatever. When you're going to Mars, you are committed. There is no abort, there's no return. And so this is psychologically a different profile. And for me, it's very interesting because there are lots of questions and ideas about how to train a crew to go to Mars. And that psychological aspect is going to be difficult for the crew to train because you can put me in, like the 500, there's the 500-day stay in the biosphere that people do. That tests your isolation capability, but it doesn't test that or show that psychological part about being on a trip that you cannot return from. So really, with dangerous repercussions. So I don't know, you might need to go plant people in Antarctica for months during the winter where if something goes wrong, you cannot escape. So the training and the psychological preparation, I don't think we have a good understanding of that yet. There are people who think that if we delay, there's the experiment NASA's trying where you do this delay of communications between the ISS and the ground, and that's going to tell you something about exploration further away. I don't agree with that because you still know you're right, the Earth is right there. So psychologically, it's a different thing. So that's what I think.
How much of a threat is space debris, and how aware are you of that threat when you're living there?
So the question was, how much of a threat is space debris, and how aware are you of that as a threat when you fly on space station? So we train for 3 major emergencies. We train for a fire, we train for a depressurization event, which would be the result of a space debris. We train for a toxic atmosphere, mainly because ammonia is being used as a coolant on the external part of the station, and there's one failure that could let it come inside. So these are our 3 emergencies. So with one of these emergencies happening, we know immediately how to react. So from the viewpoint of thinking about it all the time, not so much, because we're training for it. We know how to react if there would be some space debris. The way they operate the space station is there's sort of a box. If this is the space station, there's a box we have around it, like this. And there's a big radar system the Air Force has that tracks a lot of space debris. And if that space debris is coming into that box, it looks like it's going to come there, we work to move the space station out of the trajectory. Now, we have had several incidences in the last few years where there are items that have not been trackable. They've missed them in the tracking, and those objects come to the space station and potentially could hit because they see that the trajectory is coming close. Luckily, space is still very big, but when that happens and there's a piece of space debris that's coming towards the station, and we cannot move the station out of the way because it takes several days, what they do is they tell us as a crew, and this happened while I was on space station, during this 20-minute window when we think the space debris is crossing the space station's trajectory, you must go sit in the Soyuz and prepare to evacuate in case this debris hits. And so that's what we do. But you don't think about it. I mean, normally it's just like being at work. Your normal day, you're thinking about what you have to do that day. Oh, I've got to go do this. Oh, I have to go do this. That's really what you're thinking about. And you know that you are trained for a fire or a depressurization event or a toxic atmosphere. You know what to do because you do a lot of training. So it's almost reflex when it happens. So you worry about that on the ground while you're training.
I have two questions. One is, do you have your own free time or holidays? And also, is there any religious restriction for the astronaut? Do you do some kind of your own worship?
Okay, so the first question is, do we have any free time or holidays? And the second question, I think, is, do we have a religion restriction? Okay, so the first question, we have, of course, international component of the crew. We have people from Europe, lots of different countries in Europe, Japan, China, United States, Russia, Japan, Europe, Canada, Russia, United States. So each one of those countries has different holidays. And so what they decided to do was the crew gets a certain number of holidays. So let's say you're there for 6 months, and I don't know what the number is, it might be 2 or 3. You pick the holidays that you want to celebrate. So for example, if there was a Canadian on board, you might pick Canada Day, if that falls. Or most people pick Christmas, but you might pick, so it turns out there's Orthodox Christmas, and there's Catholic, Roman Catholic Christmas. So sometimes you'll pick one or the other. So the crew gets together and picks the holidays they want to celebrate. And the ground works around that. So that's how we do holidays. We have, on the weekends, we have time free. What we usually do is on the weekend, on Saturday, you have a half a day where you do house cleaning. So vacuum, dust, things like that. We also tend to volunteer to do science experiments. So we do extra work on Saturday with science experiments. On Sundays, we have usually the video conference with our families. And usually we either talk to every 2 weeks we have a video conference with the psychologist or our flight surgeon. And so Sundays you have those, but other than that you have free time. And then at the end of your work day, just like you go home from work and you prepare dinner and you might relax after dinner, we have that free time. So we do have some free time on space station missions. Space shuttle is a little more difficult because you're busy and you have a certain amount of work to get done, so it's not so much. But space station, you do have free time. There are no religion restrictions at all. It's completely irrelevant to flying in space. It's not even a question. So you can have no religion, or you can be whatever religion you want. It just doesn't matter.
We're on board before basically Twitter was mandatory, sort of, as astronaut. So do you think social media has changed the perception of the public of astronauts?
Yeah, it's interesting. With the onset of social media, Twitter especially, I think it's giving us as astronauts a chance to communicate directly with the general public and share our experiences. And I think it's been really great because before these platforms were available, everything that the only people we could communicate directly with was the mission control centers. And so we would call down to mission control, and the mission control could tell the public affairs people to release photographs or do these kinds of things. But now with the Twitter or Pinterest or whatever platform you like, or your own webpage, as astronauts, we can communicate directly with people. And I think that is a really great thing to be able to do. We can share pictures immediately. We can share experiences immediately. And I think it makes it more real for the public to be able to connect with people who are flying in space. So I think it's great. We didn't have that capability when I was on board. And so what I did was I sent down every now and then, maybe every 10 days or 2 weeks, a blog. So I used to write blogs about what I was doing and send that down. But it's a little more static than being able to constantly send, oh, I just did this in a more real-time, dynamic fashion. But that was all I had the possibility to do.
How would you describe a shuttle launch and a shuttle landing?
How would I describe a shuttle launch and a shuttle landing? Well, first of all, it was a lot of fun. But a shuttle launch goes like this. So we get dressed in our spacesuits about 5 hours or so before launch, 4 to 5 hours before launch, and we drive out to the launch pad, and there's a team of people there who puts us into the vehicle and straps us to our chair. We're laying on our back, of course, like everybody when they launch. And so you're normally sitting there strapped in your chair waiting for launch for about 2 or 2.5 hours. So you get out there about 2 or 2.5 hours before launch. So then you just wait. And usually you're waiting to see if the weather's going to clear up and you're really going to launch that day, and time seems to go very slowly. But then when you get to the 10 minutes before launch, it's very weird because it seems that time speeds up. That last 10 minutes goes very, very quickly. And we train that last 10 minutes very, very often. So you get into a very natural rhythm of the work that you should do, and you know what you need to do. The main engines of the space shuttle light shortly before, like I think it's 6 seconds before launch. And when we do that, because the main engines of the shuttle, if they don't work well, we can shut them down and abort the launch. So we light the main engines of the shuttle 6 seconds before launch, and when that happens, you can feel the whole stack sway, because the shuttle is still attached to the launch pad at that point. So the engines there's about 1 million pounds of thrust, and so it makes the whole rocket sway like this, and you can feel that. And then at T=0, the solid rocket boosters, those 2 orange boosters or white boosters light. That's the other 6 million pounds of thrust you need to go to orbit. Those boosters are held down by some very big bolts, about this big. The moment that solid rocket boosters light, there are some pyrotechnics, some explosives that split those bolts in half so that the rocket can lift off the launch pad. When the rocket lifts off the launch pad, it's very slow acceleration, but it's very noisy and shaking around, and there's a lot of noise, and you're trying to look at the computer screen, and the computer screen is jumping around. The maximum G that you feel at this point is 2.5. This way, through your chest. Maximum G right there. The solid rocket boosters will stay active and attached to the shuttle for 2 minutes. In 2 minutes, we've used all of the fuel in the solid rocket boosters, 2 very loud bangs and a pop, and the solid rocket boosters separate from the shuttle. Now it's just the main engines, and you're going to orbit. So the next maybe 5 minutes is fairly calm. Once the solid rocket boosters are off of the shuttle, have separated, it quiets down a bit, and it's not the vibrations are not so strong. So for the next 5 minutes, it's actually fairly calm. You have a moment I had a mirror on my wrist, and I could look out the window above my head with the mirror and see the ground drop away. We're watching the computers, we're watching the trajectory, we're making sure the engines are functioning, we're looking at the electrical system, so we're monitoring the shuttle systems. If something would go wrong, we are trained to fly manually if we need to. We're also watching our different abort boundaries, because there are different places when the engines fail that you can abort to different places. So we have to keep track of our trajectory. About a minute before main engine cutoff, we go through what's called 3G throttling. At that point, we feel 3 Gs through our chest for 1 minute. This way. And then, at the end of that, the main engines cut off, and we're in our first orbit, which is 100 miles up. At that moment, you're floating. Once the main engine's cut off, you're floating, so you're still attached. You're attached to your seat still with your harness, but you're floating. And so that's and that whole thing, it takes 8.5 minutes on the orbit. And the Soyuz is very similar. It only takes about 8.5 minutes to get to your first orbit, which is about 100 miles up. And that's what it's like. It's very fun. So to re-enter, and I'm sure you're all aware, because we're all very space smart in this room, when the shuttles would re-enter, it's a controlled fall, because we don't use the main engines on the shuttle to re-enter. We only use the engines to go to orbit. So the re-entry is actually very interesting, because the mission control people calculate the trajectory we need to go from 17,500 miles per hour and somewhere at about 200 miles up. It's hard to compute. So
please take care of your personal belongings and leave the venue.
Okay, so basically, to slow down, what we have to do is do a deorbit burn. So we have orbital maneuvering engines on the back of the shuttle. So we do a deorbit burn, which basically slows us down enough so that we're not going to stay, we basically start falling through the atmosphere. And so the shuttle would come in at about a 40-degree angle of attack, and we would start falling through the atmosphere. And we're aiming for a landing site. Say this is our runway right here. We're aiming for that a half a world away. We usually deorbit about halfway around the world. And so we come through at 40 degrees, and that's so that we get all of the heating at the bottom of the orbiter where the tiles are. And so all of the heat is going to the protected areas of the shuttle. And so as we come down and we fall, we have to control how fast we fall. And so we do that by banking. This is more lift, this is less lift. So if we bank, we fall faster. If we stay straight, we fall slower. But as you bank, of course, what are you doing? You're turning away from your landing site, because we're trying to get to that point. So as we turn away from our landing site, we go to a certain maximum angle away from the landing site. If we still need bank, we flip. And then we bank back. Oh, we're too much cross, flip, and we come back. And so there's a very...
About knowledge management, for instance. So you said that you're trained on the ground for all the experience that you're expected to do on orbit. Do you also share experience with your crewmates from the next increment, so that they know what you experienced with this particular experiment?
Yes, so the question is, we do a lot of training on the ground. And of course, we learn a lot of things. And do we share our experiences with the people? You know, like, do I share my experiences with my crewmates? And I'd say absolutely. As a matter of fact, you train on the ground to learn how to do things, and then you go to space to find out that maybe you don't do things that way anyway, because it's different in space. And so one of the first things that you do, like when Koichi Wakata from Japan came to replace me on the space station, I had a list of things that I needed to show him about what really happens with certain maintenance operations or food management or science experiments that we really do it this way, even though we couldn't train for it because it was hard to imagine, you know, where to place things. You know, maybe you need to turn the centrifuge on first and not second. Things like this, or manage the food this way, or this particular stowage area is for Ziploc bags, and this is where you go to find the plumbing supplies, and things like that. So there's constant knowledge transfer. Mission Control tries to formalize it in a crew handover book, and that gets a lot of it, but there's always some part of this that has verbal transfer. And one of the most important things that you transfer to the next person is the stowage. You take them through the station and you show them that, okay, here in the Japanese module, in this particular rack, you can find all of the materials you need to work with the freezer. In this particular rack is all of the toilet supplies. In this particular rack are all the food supplies. In this particular rack are all the crew restraints. This is very important, because it helps you work more efficiently if you know where to find things right away. If you have to go to the computer and look it up in the inventory management system, it takes a lot of time, and then you cannot work efficiently. And so one of the most important things you can hand over to the next person is, where is the stuff that you need to work? So that's very important.
Hi, could you tell us what it's like to wear a spacesuit and how you think they could improve the design?
Do you mean the spacewalking suits, the big white ones? Okay, the EVA suits. So those are very interesting, and as a female, that's one of the more difficult tasks that we have, because those suits were designed for very large gorilla-like men. And so as a female with narrow shoulders, it's a little more challenging. As a matter of fact, I was in the smallest, in the United States, we have a suit that is a pair of trousers separated by a hard upper torso, and they can adjust the arms, and I happen to have long arms, which is very helpful. They can adjust the arms, and they can adjust the legs, but they cannot adjust the shoulders and the volume from front to back. And so, for example, I was in the very smallest suit they have, and the shoulders hit me here and here instead of here. And so the bearing, the shoulder bearing was here. So I lost a little bit of mobility in my arms because ideally this is where your joint is. So this is where you want the suit to rotate. So I had to rotate here. And so that's very challenging. So when you think about designing a suit, you have to think about where the joints, how you can make the joints match up, because you need mobility. And for example, this motion was very hard in the suit, and so if I wanted to do something like this, I really had to do this, because the bearing in the suit was designed to go this way, not this way. And so you really have to think about the design of the suit, what your joints can do, and how you want to operate it. So the most important thing that you have to deal with are the gloves, though. You think about the kind of tasks that you're doing on a spacewalk. You need to have very good control of your hands. And so gloves are very important, and they're very key. And so I actually had gloves that were molded to my hand, because I have unusual hands for a female in that I've got very long fingers, but I've got very skinny palms. And so I fit in the gloves with the men who have long fingers. I fit in their gloves, but my palms are smaller, and so I could put two of my hands in the palms. And so I actually had a pair of gloves made for me that other women use who are like me. So gloves are very important as well, so that's something to pay attention to. So I would say the joints and how the joints move and the gloves are very, very important.